So next point we are to discuss is the ionic radius. Ionic radius is the radius of an ion in the ionic crystal, or it is the distance from the nucleus of an ion up to which it has influence on its electron cloud. So the electron, why we discuss the electron cloud here, an ion, the electron cloud density or the electron cloud quantity changes when it becomes a cation or an anion. And here also using the X-ray studies, you can find out the internuclear distance. And this internuclear distance is taken as the sum of ionic radii of two ions touching each other in the ionic crystal. If you take a sodium chloride ionic crystal, because why you cannot measure simply the half the distance as we calculated for the covalent radius or the van der Waals radius, the two ions which will touch each other in ionic crystals will be ions of two different elements, and one will be a cation and the other will be the anion. You can never hope to place two cations altogether or two anions altogether. Because of the electrostatic repulsion, they will not exist like this. So by X-ray diffraction studies, you can calculate the internuclear distance, but you cannot simply take the half the distance as the ionic radius, because one ion will be smaller and another ion will be bigger. Say for example, if you take a sodium plus ion and a Cl minus ion, in the ionic crystal of a sodium chloride, sodium ion and a chloride ion will be closer. The X-ray study will reveal the distance between sodium nucleus and the chlorine nucleus. Half of that is neither the ionic radius of a sodium or ionic nor the ionic radius of a chlorine. That is why the definition is clearly given as it is the distance from the nucleus of one ion up to which it has the influence on its electron cloud. So it can be taken as the sum of ionic radii of two ions. So the ionic radius here, what is the ionic radius of sodium plus ion and what is the ionic radius of Cl minus ion? If you sum up these two, you will get the internuclear distance. You say in the case of cations, cations means ions which are positively charged, or the ions which are formed by the loss of electron. Say lithium, after losing one electron, it becomes lithium plus. Actually, this one electron is in the 2s1 orbital. So losing that one electron is something like losing the entire shell itself. So lithium atom is 1.34 angstrom unit size. But a lithium ion, after the loss of one complete shell, it becomes 0.60 angstrom unit. See, the ionic radius is 0.60 angstrom unit. Atomic radius is 1.34 angstrom unit. So the cations are always smaller than their corresponding atoms. Similarly, magnesium, which is the atomic radius is 1.30 angstrom unit. Magnesium 2 plus, after the loss of two electrons, it loses one complete shell. One shell itself is lost. Therefore, it becomes 0.65 angstrom unit. So the size of the cation is smaller than the size of its own atom. And also here, the decrease in the size is not only because of the loss of the shell, it is also because of the remaining electrons are effectively attracted by the nucleus. Because previously, say for example, if you take lithium atomic number 3, and the 3 protons are attracting 3 electrons. After the loss of one electron, what happened? One shell is lost, and also in the new situation, the 3 protons are attracting 2 electrons. The proton charge is higher than the total electron charge. Therefore, the 3 protons attracting 3 electrons, now the 3 protons attracting 2 electrons, the attraction will be much more. So, the ionic size is small in the case of cations. It is not only because of the loss of one complete shell, it is also because of the effective nuclear charge or the nuclear attraction felt by the outermost electron. But in the case of anions, additional electrons are found. Hence, the total quantity of the positive charge is less compared to the total quantity of the electrons. Therefore, what happens? The outermost electrons are not effectively attracted. Therefore, they try to be little far away. And also, the additional electron may sometimes take place in a new orbit. But we are not discussing that because chlorine is a p5 electronic configuration. The addition of one electron it is taking place in the p6 in the same shell, but there is an expansion in the size. See, it is a 0.99 angstrom unit, the atomic radius. The Cl minus ion, it is 1.81 angstrom unit, goes far away. Bromine, it is 1.14 angstrom unit, but bromine minus 1.95 angstrom unit. But in general, we can say anions are bigger than the atom itself. These are all the important ideas we have seen. Good. You should understand this one particular point. Sodium 0 is highly unstable. Even you can put a sodium metal in water and you can see the vigorous reaction taking place. The vigorous reaction is due to the metallic sodium, and you can see sodium combining with water to form sodium hydroxide, and the liberation of hydrogen is also observed. But a sodium plus, if you put into water, it will simply go into the solution. No vigorous reaction is observed. It is only because of the unstable nature of sodium 0. Similarly, Cl0 is unstable, but Cl minus is stable because by losing one electron, sodium gets octet, completed octet. By gaining one electron, chlorine gets a completed octet. That is why when you place a sodium and chlorine together, there is simply a transfer of electron from sodium to the chlorine. Because of the transfer of the electron, sodium becomes a smaller ion and chlorine becomes a bigger ion. That's all. So previously, sodium atom was of a particular size, chlorine atom was of a particular size. After the transfer of the electron from sodium to chlorine, sodium becomes a smaller, correspondingly chlorine becomes bigger, but this increase in the size of the anion or decrease in the size of the cation, this is having no relation with the attractive force existing between the sodium plus and the Cl minus ion. Sodium plus and Cl minus ion, the ionic bond is purely an electrostatic attraction. It is purely an electrostatic attraction, which has nothing to do with the ionic sizes. So it is an electrostatic attraction between a positively charged species and a negatively charged species. So ionic bond is strong. It is because of the electrostatic attraction. It's not because of the size of the ions. All right. Any other question? Anybody else have any question? Nishita Peter.
Sir.
Any question?
No, sir.
No question. You don't have any doubt.
No, sir.
See, the two people, they do not ask any question. One who has completely understood everything, one who has not understood anything. Aishwarya. Number 1.
Sir, I didn't have any doubt now, sir.
Okay. Number 11. 11.
Sir?
Any doubt?
No, sir.
No doubt. Okay. In which school you studied?
Sir, in a St. Xavier's High Secondary School, sir.
Where? Here?
Yes, sir.
English medium or Tamil medium?
English medium, sir.
Very good. Very good. How? What is your mark in chemistry?
Sir, 70, sir.
70. Good. 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 Right. Number 12.
Sir.
Where did you study?
No, sir.
Where did you study?